In this session, we are just going to discuss about the numericals on the gravitation, students. So, welcome you all. In this today's sessions, we are just going to discuss about the numericals on the gravitation. We have already seen about that, what are the concepts of the gravitation. So, the first question here, two objects of the different masses falling freely near the surface of the moon would be. You are having an option, have the same velocity at any instant, have the different acceleration, and the experiences forces of the same magnitudes, undergo a changes in their inertia. In this question, you see, students, two objects of the different masses falling freely near the surface of moon would. You are having a four option, have the same velocity at any instance, have the different acceleration, experiences force of same magnitudes, undergo changes in their inertia. The peoples are just, without knowing the concept, what they do. They are just giving a assumption answers. But here you understand the concept. Suppose this is the moon and this is your any objects you have taken. Their mass is m1 and the mass is m2. And their acceleration due to gravity, that is the g dash and g dash. Because here the air resistance is 0. And we are just going to free fall from the same height, that is h. And we know the formula, capital F is equal to capital G, capital M, and m1 by h square. And here that our force, that is the m into a. So m1 into a1 is equal to capital G, capital M, and small m1 by h square. So this m1 and m1 is cancelled, and a1 is equal to capital G, capital M by h square, that is g dash here. Same again, we are just find it out for the second object, that is acceleration, that is a2 is equal to capital G, capital M by h square, that is also g1. So that v is equal to u plus at formula, we are knowing that, and here the u is 0 and a is what, that is g dash. So this g dash I have taken nt, so that v is equal to z dash t. So objects of the different masses falling freely near the surface of the moon would have the same velocity at any instance, because they will have the same acceleration. Okay, same acceleration due to the gravity. In this question, students, you see the earth attracts apple from the tree and it falls on it, but the earth does not move towards the apple. Why? Again you listen the question. Earth attract apple from the tree and it falls on it, but the earth does not move towards the apple. Why? Here the one student has raised the hand. I want to ask. Yes, Shivans Pathak. Telling you that earth attracts apples from the tree and it falls on it, but the earth does not move towards the apple. Why? Because the apple fall towards the earth, but the earth does not move towards the apple, because acceleration is inversely proportional to mass, and earth mass being extremely large, because the size of the earth is larger as compared to the apple. So it is negligible acceleration, students. So it is negligible acceleration towards the apple. Got it? In this question you see, students, it is written, is uniform circular motion taking place at a constant speed or constant velocity? Is uniform circular motion you know well, taking a place at the constant speed or constant velocity? Why? So this is your question. Here you see, students, an object when moves in a uniform circular motion, what is the next? it is having a constant speed. And what is the next?
Is not changing,
Okay.
but velocity is changing because the direction is changing
Okay.
continuously.
Okay. To tell you, an object when moves in the uniform circular motion, it is having a constant speed. Second important things, while the speed of object is constant, then its velocity is changing, my dear. Thank you so much. You have given me that answer. And velocity being a vector, because you know well. And it has a constant magnitude. But after that, what is the next line? So magnitudes, but a changing direction. So that is a very good answers you have given, students. And objects when moves in the uniform circular motion, it is having a constant speed. While the speed of object is constant, its velocity is changing. And velocity being a vector, so it has a constant magnitude but a changing direction. Next question, students. The value of the acceleration due to the gravity is same in equators and pole, it is less on the pole, or it is less on equator, or increase from the pole to equator. Your diagram is just like that. So it is at least the equators and a maximum at the pole. Why? Because the rotation of the earth. So it is given by this. You see, this is the circular path and this is the equators. So these are the m w square r. So that it is least at the equators and maximum at the pole due to the rotation of earth. So g dash is equal to g minus CO2 r sine theta, and at the pole that is the theta is equal to 0. So the g is maximum, and at equators that theta is equal to 90 degrees. So the g is maximum. So it is least at the equators and maximum at the pole due to the rotation of earth. Because most of the time you are giving me that answers, but you are not giving me that. This is the question. Name the force which is required to maintain a body in uniform circular motion. Oh, Shreyas Shukla has given that one answer. Anyone else? Come on, every fast finger, fast finger. Only the Shreyas Shukla has given answers. Rest other students have not given me the answer. Quickly, my dear. Achal also given the answer. Very good. Others Tiwari also given answers. But what is right and what is wrong, I am not telling that. So must think and then you give the answer. Sejal. Again I am explaining you, Sejal. Name the force which is required to maintain a body in uniform circular motion. You have done this activity also. You have taken the stone and tie up with the threads and you are just moving. And that time which force is going to balance you? Shivans Pathak is also given that a congenital force. Okay. Okay, students. Very few students given me that answers. That is your centripetal force. See the spellings also. So thank you so much, students, that you have just given